So hey everyone, welcome back to my channel. This is Lakshay here. So today we're gonna start with the lead code question number 78, which says subsets. So it's a medium level question in our lead code. So let's read it down first. So it says given an integer array nums of unique elements, return all possible subsets means the power set. The solution set must not contain duplicate subsets. Return the solution in any order. So here we only have to what we have to do. So here we have to do is just we have to create all the subsets of the numbers we are given here. Okay, for example here we are given 1 2 3, so we have to create all the possible subsets, means a power set which we can form from these numbers. So we can see a pattern here that here their total numbers are 3 and we are forming total 8 subsets, and here our numbers are 1 only and we are forming 2 subsets. So from this we can infer that number of subsets will always be 2 to the power n, where n will be our number of integers. Let's write it down, number of integers. So in the first case we have 3, that's why we are having total number of subsets 8. Okay. So how we can approach this problem? So we can approach this problem through our recursion only, but how so? So let's see. Let's take the first example. Let's suppose we are having this array. This is our nums array which containing all our integers, and we have to take each integer at a time. Means how we can form, like, this is our answer basically. One should be paired up with alone, then one is paired with 2 also, then one is paired with 3 also. Similarly 2 is paired with 3, and then they all are paired and they are also alone, like this, like this, and at last an empty set, means nothing here. Okay, so this is what we want. So how we can approach it? So we will see, let's first see it how we are approach this problem with the help of our recursion tree. Okay, so at starting what we are, this is our array and this is suppose our index, and it is currently pointing at 0, and this is currently our empty string here. Okay, so what will be our first step? We can push our index. Okay, our first index where here we are pushing means 1. Okay, like this. Now there is another approach also, that we don't push anything. Okay, there always be two options, either we push or we don't push. So like here we have pushed, but here we haven't. Okay, fine, we are not pushing anything. Then our index move to next here. Then again we are at second index, so we have two options, either we push 2 or we don't push, means still we are only having 1. Okay, because we are not pushing. Here also we are having two options, either we push or we don't push. Okay, so if we push here, so we get 2. If we don't push, we keeps our empty string. Sorry. Then next step again, our index moves further. Okay, it is now pointing to 3. So now we know that it is pointing to our third index. So again we got two options, either we push our 3 or we don't push, like this. Here also either we push or we don't push. If we push we got 1 3. If we don't push we only got our 1. Here also two options, either we push 3 or we don't push. If we push we get 2 and 3. If don't, then we only got 3. Here also we are having two options, either push or don't push. If we push we only get a 3 because it's already an empty string, but now we push 3. And if haven't pushed, then it's empty string. That will be, means like this now, have only pushed 5 is nothing, that will be this empty string. Now we can see that our index has already reached our end value, means there is no further value here. That means it has reached all the, and it has traversed all the values. That means this is our answer here. Okay, so after reaching all the values, this is our answer here. So how we can perform this problem recursively? Let's write down the pseudocode first, then you will understand more clearly. Okay. So first of all, let's create vectors. First we created a vector result, and then we also created a subset vector. Okay, we have created two vectors, result and subset, and then we will call our function here, that will be create subset. This will help us create all the subsets that we are having here. This will help us create all the subsets. So we will pass our nums array, that is our given already in the question, then our index which will be 0 at the starting, and then our subset and our resultant array. Subset will contain this, like one subset is this, second subset, third subset, and our result will contain all this. Okay, that's why I created this both two vectors, and at last we will return our result here. Okay, that will be our main function. Okay, let's write function here. Okay, now let's write down our create sub function. So let's continue from here only. Create sub. What we are having, our nums, our index that is currently 0, our subset, and our result. Okay, so first of all, what will be our base case for this recursion? First of all, we will always check that if our index is now equals to nums dot size. Okay, it means that it has traversed all the values and now it is exceeding our limit. Okay, then what we will do, we will simply perform result dot push back our subset. Means whatever we have pushed our subset till here we see that we have pushed these values in the subset. We will simply push these values in our result. Means now our result will contain a subset like this. Okay, like this. That's why we pushed here. We will simply return. Means that don't perform function here, we will return it. Okay, but if not the case, that means we haven't traversed all the elements yet. So what we will do, we will first of all push that element. Okay, how we'll push it? It's like this, subset dot push back the element at that index. That means we will push the element at nums of the index, like this. Okay, and then we will call this function again for further indexes. Okay, then what we will pass here, same num, but now we'll pass our index plus 1 because we now have to check for the next index, that either we can push our next index or not. Okay, and then same our subset and our result. After this, now we have checked the condition when we are pushing this element. Okay, like 2, for example, we are at 2 and we are pushing it, but we want to also check the case where we are not pushing this element, we are directly moving to next index. Okay, but here we are pushing then moving, but now we have to check the another case also where we are not pushing but still moving. So how we can check that? We will perform subset. We have, because we have already pushed it, so now we will pop it. Okay, we have popped it, so now a string subset is not containing this element. Okay, then we will call the function again like this, and pointer will be pointing to next index because we are just excluding this, but we are continuing with the next index like this. Okay, so this is our only basic pseudocode. Now let's see again how it is approaching our problem. Okay, so we know at starting we are having nothing here, just an array 1 2 3 pointer here. Okay, so first of all we are having options, as let's jump in the code. So first of all our function is called like this, it's creating two vectors. Let's create here only result, let's create here subset. Okay, and we'll start with down. Okay, so at starting the both are filal empty because we haven't pushed anything yet, and we are calling our sub function create subset. Okay, so we call it, so now it's called it like here. So at starting our index is 0, we can see here our index is 0, so it checks if index equals to nums dot size. Nums are sizes, our size is here 3 we know, and our num is currently at 0 index, means our index is 0, so it's not equal. So it calls it, what it does, so it break down this loop, means it don't goes here in this condition and directly jumps here. So it says subset dot pushback nums of index, means what we have to do, we have to push our value to our subset. So now like our subset is look like something like this. Okay, now we push this value, that is the value we are pointing with our index. Now what we will do, now we have called again create subset, means we have called again this function here, but now we have passed our index plus 1, means now our index is pointing to here like this. Okay, then again it checks, now index equals to 1, means our index is pointing to 1 index now, it's 0 and 1 and 2. So it 1 is equals to 3, no, that means we again goes to this, that subset dot pushback, so we push it again here 1 2, then we again call this function, so we pushed again here 3 like this, then we again called but with index plus 1, means now our index is here, you understand, means at third 3, and we know the 3 is are also a size, that means we are exceed our limit, so that's when we will return. Okay, so from here we will return. Okay, so we are something here, we are here, and now we are returning. So when we return, we are currently at here. Okay, and we are currently having two conditions, that we have already used 3 because we have written at this stage. Okay, where we have only these two elements, and now we will perform, means we are having this, but now we will perform this operation subset dot pop, so means we are popping now. Okay, that we have popped here, and then we will get another string 1 2, and index is again reached. I think I should explain you with the help of tree only, that will be more beneficial. So here's a tree starting at 0, then what we have done, we have called for 1, so we are having 1 like this, then we called for 2 and we got 1 2, then we called for 3, we got 1 2 3. Now what we did, we returned, you can see here we have returned from here, so it returns here now. Okay, no, sorry, I understand, we are calling again here. Okay, we can see here because we have called again, that's when we understand that here was third, here was 0 index, here was first, here second, and here was third. We understand that we have reached a limit and then we return from here like this. Okay, then we can see that we have 1 2 3 total 1 2 3 elements. So what we did, we did the pop operation here, so we popped it and we called again create subset for the next index. Okay, so what we did, we called the create subset function for the again the third index, but then we know that we will again reach our limit, so that means the only string we got from here is 1 2 3. Okay, like this only, because then we will know that it again calls the same and it will reach our null. That's why we call this it traverse back. Then again we reach here, then again it got two options because we have now removed, so it got 5, then again we calls here for 3 and not 3, then same like this only, here we will get a string like this 1 3, and then here same. So this is how we're gonna approach this problem. It's super simple, just you have to keep on traversing and you have to just do the dry run so that it makes you more clear. Okay, so let's jump down its original code. By the way, it's a pseudo code, and below is the our important code that will contain all the test cases. So here is a code that you can directly use in your LeetCode. So it's same, we created a vector result, a vector subset, and we called the function here, and at last we are returning a result after all this operation. And it checks if our index has reached the last pointer, means our size, then it pushes, then it pops, and again calls the same for index plus 1, index plus 1. So let's discuss the time complexity now. The time complexity is big O of n into 2 to the power n. And why so? It is so because we know that we are following 2 to the power n subsets. That's why we are having 2 to the power n time complexity. And also we know that there will be maximum of big of n times that we are copying our subsets to our result. That's why big of n times we are copying So max can be big of n. That's why its total is our time complexity. That is this. Same is our space complexity. Its complexity is also big of n cross 2n. Okay. Big of n. Why so? Big of n is because we are creating a recursive stack every time. This is all our stack. Like this, we are storing element, then we are going here, then again storing something. This is basically our stack only. And big of n to the power n is, we know that the subset we are storing. That's why. So that's why this is our space complexity and this is our time complexity. Okay. So that's it. There is a code. You can try it down first. And thanks for watching. Bye bye.